Hi, good people. Today we are doing the last part of our deploying to the cloud. We have been going through a journey of how we deploy softwares on the cloud. We have looked at Docker. We have looked at Kubernetes, but I want to recap from the first step. What are we doing and why we are doing this? Someone told me that they didn't get the concept of what this is all about. Yeah. So one of the things we start by a recap on what we are doing. We when it comes to cloud computing, it's everything to do with getting someone's computing power, then you pay them. Like we have data centers, Amazon. For example, we have Amazon AWS, who give out Amazon AWS, who are cloud hosting. Basically, they have data centers all over the world. They have data centers in Europe, they have data centers in US, they have data centers in Africa. And in these data centers, they have machines, servers, and they are leasing these servers. They have different services that they sell, and first we buy their computing power. We buy the space for our database. We lease the machines for a specified time. So, for example, there are different, as we said, cloud computing. There are three main. It's divided through three main distinctions. We have what we call service, software as a service. This is the basic part of it. This is like when you go, there's a already made software that is deployed. You just use it, you pay for the use. That's software as a service. You have platform as a service. You are given a platform, then you deploy your software on top of it. And you have what we call infrastructure as a service. Infrastructure as a service is what we have been looking at. That's why we use Kubernetes, we use Docker. So what we have been doing is just after we have done our application, first we need to do our application. We write our code. Our code can be in any language, can be in Python, Java, or any other language. Then when for example, we have what we call virtual machines. Virtual machines are what we call virtualization. We have the physical machine that has RAM, ROM, and cache, and CPUs, and memory, all these resources, and we want to make use of them. So we can have them as many as we want. We can have mini machines. Let's say when it comes to like AWS, we can deploy. Let's say we want some machines that can do basic stuff, machines that can do just deploy our website. So we go for the lists. This is not where I wanted to go. And there are different cloud hosting companies. We have Amazon, we have DigitalOcean, we have Microsoft Azure. We have quite many of them, and they give all of them give software. They give software as a service. They give platform as a service, software as a service, and also they give infrastructure as a service. So we've been looking at infrastructure as a service, where you are given like an empty machine. It's just you first, like the first time you buy a computer, you install a operating system on it. Then you go ahead and install the softwares. So that's what we do to run our softwares, because we are not, let's say we have a cluster of machines, let's say 10 of them. So when you want to manage them, it's easier when you use your machine is just one, but you want to manage them. That's why we decided to do this. I'll be talking about Docker, what Docker is, and then do Kubernetes. This is a recap. We have done this in previous videos. So we have Amazon, who do sell their services. We have Azure, which is by Microsoft. We have DigitalOcean. My internet is a bit slow today, so we have DigitalOcean. We have. You can have. There are so many, and most of them give similar services. Like if let's say you see virtual machines. The virtual machines, they have CPU, they have memory, they have CPU, memory, they have probably block storage, let's say EBS, and they charge most of them charge per hour or per second. It's according to what you'd like, how you'd like it being charged. And so after we get our machines, we want to deploy our application. We have application, we have virtual machines, and then we want to deploy our applications on those virtual machines. So what we do next, we deploy software that will help us, we install software that will help us deploy those softwares. So what we do is probably nowadays we do a lot of distributed systems. Almost every software you write to be a distributed system. To have some services running in one data center, others running in another data centers, and this is the way things are done nowadays. So, and yeah, for when we started, we talked about why we need isolation. Docker is just for isolation. We have an application that needs a different runtimes. Let's say we have our front end that needs Node version, let's say 8 to run. We have a backend, let's say, written in Express that needs Node version. Let me see, Node version 12.14 or any other. So we need to isolate. We can't use the same node. Node is for JavaScript. We can't use the same node for all of them. So what we do, we put an application into what we call container. Container is the similar idea with containers, but for the ones used for shipping. The ones you used in shipping, like these ones. So inside our container, we put everything. We put a node version that we want to use. Inside the container, we put everything. Then we can have these containers on top of our cluster. Our cluster will be managed. Our cluster of machines will be managed by Kubernetes. So we talked about how to install Docker. If you're on Windows, you download a Docker desktop, which comes with Kubernetes installed. You just run. If you're on Mac, you use the Docker desktop also for Mac. For Linux, you install VirtualBox or VMware workstation, then you install Docker. You install Kubernetes. That's for Kubernetes. For Docker, you just do Docker pull, and that is it. So so we did Docker, and we did quite a number. We said if you want to run Docker, first you run what we call for Windows is that you click some few buttons and turn. For Linux and Mac, you have to start what we call Docker D. Docker D is, let's say, Docker D is a daemon. It's a background. It's a background process that needs to run when it's like serving when you are doing our stuff. It's the one serving us. So let me see if Docker is running. Docker, but I'm just checking if my Docker is running. So these are the modern way of deploying softwares. We have software. Most companies nowadays, from Google to Twitter to Facebook, almost everyone uses containers. You put an application in a container, and you have all the resources needed for that container inside the container. Then you deploy it on a cluster. It can be a Kubernetes cluster. Sometimes people use Apache Mesos instead of Kubernetes. Apache Mesos is just for unlike Kubernetes, which is orchestration. That's orchestration for containers. This manages your resources. It manages your CPU, it manages your RAM, it manages all those stuff. It's like you are running your application on your laptop. You don't mind if for example, my laptop has 4 CPUs, it has 8 threads. I don't care. When I'm running an application, I'm not concerned about which CPU runs what. So this is exactly what Mesos does. And you can also run Kubernetes on top of this for orchestration, for container orchestration. So today we looked at, let me see if it's running. So we did a lot. We did Docker PS, and people have been telling me that they don't understand what we've been doing, and okay, I wanted to look at the last part of what I wanted to do, which is persistent volumes and persistent volume claims. But today I'll delve more on what these things are. So we said Docker, what Docker does, and we said how to run it when we talked about this. So remember, you can ask questions on this group. This group is on WhatsApp, and you can post. You can ask any question about everything, and there's no stupid question. Any question is welcomed. So just ask any question, or comment or anything. And be honest. If there is anything that is not good, just say we can improve here, and we do that. This basically these live sessions are mainly focused on you becoming good at what you do and learning how to do it. If you have not learned, you just say, how did you do this? It's not important. It's not that important for me to just write commands and code, then you don't get it. It doesn't have the purpose. So we if there is something you didn't get what was happening, you just ask, and I'll do it. I'll show you how to go about it. So we have a, let's say, we have an application that serves, let's say, schools. We give an example of schools. We have different schools that need different uh, uses. Let's say it's a school management software, and we want to deploy it and then give the service for, let's say we charge for service. So each school needs their own configurations. Each school needs, they have different use cases. So how you deploy this, your application is not the same for each. So let's say applications are divided into front end, backend, and you have databases, and so you have some Docker containers running your front end, other Docker containers running your backend, and there might be many of them. So the front end is where the business logic is, how to data is taken from the front end and stored in a database, how it's analyzed, how such stuff, and if there's emails to be sent, to, let's say notifications, let's say after the school is over, the school term is over, we are sending results for students to the parents. So we send maybe an SMS, an SMS notification, or we send an email. If all of that will be done by our backend, but the presentation there, which is like what I'm seeing here, this is done by using a different, mostly is HTML, CSS, and JavaScript. You have containers, Docker containers running the front end, other Docker containers running the back end, and database is running. So we talked about how to run. Let me see how you run this. You first have what we package our Docker containers, our application, the code we wrote, and I had written what you call an application we did on front-end Monday. We called it FEM. Then we used a Docker file. We Dockerized the application, and next after Dockerization we ran it, and yeah, that's what we'll be going back to. And for 1 minute we look at it, then we go back to Kubernetes and learn what Kubernetes does. So let me look for that application. Actually, if you check here, because I had Dockerized it, we can do sudo. Sudo is on when I want permission on my machine. This has nothing to do with Docker, but the next command, which is Docker, then I do images to show me the images. What images is when you package your application as a container, what you get is an image. And this is what we push to our, what we call a registry. A registry is where we put, is a storage, where we put applications so they can be accessed by, when running it, either by Kubernetes or us, if you are running it manually. So we have this FEM app as one of our images. We have FEM, we have this what we did last time. We are doing load balancing on layer 7. We were doing, before we did load balancing, the normal load balancing, then we became too tedious. We said we would talk about load balancing using layer 7. Layer 7 is just, if you did, if you know something to do with networking, I'm not assuming you know, just starting, is what we call OSI model. This is a model for networking, and the internet is quite slow. So these are internet for networking, and These are model for networking. So we have different layers of network. So this is what we have here. We have our application layer, we have a presentation layer, session layer, transport, and this is the physical, this is the hardware part of our network. And then we have, this is quite important nowadays, transport layer. Now we usually do what security nowadays, we do TLS, transport layer, and what we are talking about layer 7 load balancing. This what was it, load balancing on your application, not the other part of the network. So this is what we are talking about, layer 7 ingress, not egress, ingress, using Nginx. And yeah, we have a node image, we have Elixir, this one, we have another load balancing. Before, if you're not using Nginx ingress or Istio or any other, you can use normal load balancing, you can use HA proxy. And this is another application we put from Docker Hub, and then we run it. So what we are going to do, let me look for the commands we did. This is how we search on Linux. This is a search. I'm just doing a simple search, and then I'll do FEM app. We see all the commands I have been running for FEM app. So here they are, and this is what I want to run. Docker run. This is how you run Docker images, and I'll just copy and paste. What we have here, we have Docker run, then we have this, we call those flags. You can have -p, you can have -p is for port, this is the port. You can have -d, which means it's a daemon, runs on the background, but we don't want it running in the background, we want to see it. So we say we are using port. This is the port. It was a Vue.js application, and this is the default port on Vue.js. So we want it to this is a container or image port, and we want to access it on port 1992. So I'll just hit enter, and then we'll see it on our browser. This is the manual way of running our application. So our application running on these two. On my local IP, this is localhost, and this is network IP. So if you come here and paste this, we'll see this application. No, it's not running on that port. Actually, it's running on 1992 because this is the port we mapped to. This was it. It was just an JavaScript application introducing Vue and React. So we ran this application. What we do when you run Kubernetes, it does this for you automatically. Sometimes virtual machines do go down. Not sometimes. It's expected. Failure is expected almost every day, almost every time. A virtual machine that's running our application goes down, and you need to provision. You need to start another Docker, another instance of your application, so it can continue. So this is what Kubernetes does for you automatically. It runs this, and because probably this application runs, let's say it starts, you have 50,000 clients, and all these 50,000 cannot be served by one instance like this application. Just this, you need different instances. If you have like 50, you need 10, 5,000 each serving 5,000. This depends on your computing power. So for this, you in Kubernetes, you say I want 5 or 10 or 15 instances of this, and we have seen actually some organizations, some of online services, they have thousands and thousands of these. For example, let's say for Apple, Apple or Apple, they have what we call virtual assistant Siri. Siri and Siri like has a database. They use Apache Cassandra database, and this one they run several hundred thousands of databases. So you can see if you are running a database, you have all those instances. You can run as much as instances as you want according to your customer. And the other thing that now we are getting Kubernetes. The other thing Kubernetes does is that it can scale up or scale down very easily. It helps you if users go down. If peak time you had 10 users on not peak when you those during the time it's not peak you have 10 users. When it's peak you have like a million users. So how do you scale? You don't want to be using resources. You don't want to be paying for machines. So Kubernetes can help you scale this. So I'll be starting Kubernetes. This is how Kubernetes on my machine, or if on your machine, if you have not provisioned a cluster um, on cloud hosting, you install Minikube, and then you run Minikube. This is how you start it. We wait for some time as it starts. As I said, you need to have a virtual machine. I had to install VirtualBox on my machine, and yeah, as regards to give us a way of deploying our application. If I can say something about. Someone asked me how is it different from the way most of the time we deploy our, let's say, our website. You buy hosting, let's say, for a few thousand shillings, then you buy a domain name and deploy. Like you have what you call cPanel, and you deploy your application there. Almost every website hosting company has a panel, and it has quite a number of services. You deploy your website there. How is this different? When you are deploying on cloud, you have the flexibility of using what you want to use. For example, when you're using cPanel or cPanel, you use HTML, CSS, and JavaScript. Then you probably use PHP as for your backend. Most of the people use PHP. I've seen some web hosting supporting Python, and a few, when it comes to database, they will support MySQL, and I don't know about Postgre, if they do support Postgre. Mostly you won't get a database like Oracle, and you are limited to what you can use. And also when you buy, for example, when you buy from a website hosting company, you get, let's say, a bandwidth that is fixed. You get they won't even tell you what the CPU capacity is. So it's good for small websites, but when you want to have big scalable business running on it, you can't afford to use this. Say, for example, what we do, we do a software for a whole system which is for insurance. Insurance company runs a huge application that does on everything to do with general insurance. It does we have email server, emails for the whole company. we have a file server. So the use cases we have, let's say we have transactions that are not let me say transaction, M-Pesa transactions, which they need to be taken in through an API from Safaricom. We have so much of the needs we have cannot be supported by a cPanel kind of deployment. So that's why we go for cloud hosting. Then we can have more control of what you use. For example, we don't buy hosting from any company. We have our own server room, and in our server room we have servers, huge machines, and these servers go for. I checked on the price of these servers, and they go around. One server goes for 380,000 Kenya shillings to 400,000 Kenya shillings. So if you are for an organization that can afford that, but if you need that computing power, you can list it because you don't need after that machine you're done with it, you don't need it. The other thing for applications like on-site data center or a server room, uh, we have to keep that application running even when very few people need it, and that's not quite efficient. That's why we go for most companies are going for cloud hosting that is scales down when a few people are using and scales up when many people are using. So let's say we are in our headquarters, and we have in our headquarters we have a few hundred people using the system. And when you go to branches, let's say like today we close at 12. At 12 we don't switch off the machine, we leave it running even on Sundays. Probably someone is using the infrastructure, the software, when on or after 12 on Saturday. So we have to leave it the whole power. First of all, it needs a lot of cooling. It needs a lot of cooling, and it consumes a lot of power. So you check the bills and say no, there's need for a cheaper way. Cloud hosting gives us a better way of doing it, doing this. So that's why we need to learn how to do cloud hosting, to do cloud computing. So if we were to run our application, let me, for example, give an example. We have a general business software and our general ledger software. General business deals with everything to do with underwriting. If you know the insurance process, there's underwriting, there is claims, there are quite a number of this stuff. So our general business software caters for that. If we were to run this application on cloud, we'll have one service which is for underwriting, which is the main part of our business, running for like several Docker containers running that application according to the number of the users we have. For our claims, maybe we have five instances, five instances of one Docker image running, and that's why we need cloud hosting, and we need to go for this. It's cheaper. One is cheaper. It helps you scale, and it makes things way easier. The only thing it comes, there's an overhead. The overhead is technical debt, and technical debt is like now you need to know how to deploy softwares on the cloud. You need to know the developers need to know a lot of stuff for this to work. So first you need to know stuff like Kubernetes, You need to know stuff like Docker. That comes with the need with us changing from using probably using cPanel or using in-house server room. And yeah, so what you do, I have my Kubernetes cluster. Kubernetes it manages the main thing about Kubernetes is managing our containers. Let's say we have a we say we have a container. For example, let's say a general business software, and we in our general business software we have a service for the underwriting, we have a service for claims, you have a service for certificates and all that. So we want to manage the whole of those applications to run in harmony and to scale up when it's needed, to scale down when it's needed, and how much of resources they will have. So we use Kubernetes. Each of those services will be a Docker container, and you can have like 2 Docker containers that are doing exactly the same thing. And we said last time, we said for us to, let's say we have 100 people using these services and we have 2 of them, we use what we call load balancer to, like, it's balancing the load. If two services and each can handle 50, so the load balancer will give 50 to one and 50 to another. And there are quite a number of way of doing load balancing. There are other what we call like canary, where you can say I want 95% of my traffic, my 95% of my load to go to one application, one instance, and 5% to another. There are quite a number. That's what we are talking about in the last 2 sessions, where we talked about load balancing and layer 7 load balancing using Kubernetes Ingress. So what we do, and let me start dashboard, which Minikube dashboard. So the dashboard helps you to, let me copy this and start it here. I have a bad flu, that's why I'm talking differently today. So okay, this is our dashboard. What a dashboard is a way. There are many ways to interact with our Kubernetes cluster that is running. You can have this dashboard even when on cloud, so it makes you easier. So this is what you do. We have been talking about different Kubernetes. We have been talking about different Kubernetes concepts. We talked about pods. Pod is the smallest unit of deployment. It can have one container, Docker container. It can have 2 Docker containers. It can have not many, but when a pod dies, let's say the system where it was running on, the server goes down, so the pod dies with all the containers. So that we say everything in a pod, they have the same lifetime. Like it's when they come up together. When they die together. So we have these are our containers that we are running, and we can see these containers, how you get them. After you create your images, what we did after you create your images, my machine has hanged. After you create your images, what you do, you store them on what you call Docker Hub. And we say the Docker Hub is a storage. It's a storage for our containers. That's where our, let's say Kubernetes, will pull containers from. And Docker Hub is free, but it comes with a caveat that it's public. If you don't pay for privacy, Docker Hub will display your container for public, and anyone can access. your application. But if you pay, they have privacy, private, where you can put your containers there, and you have your Kubernetes, or you pull your application from there. So if you come here and let's say a repository, I think there's no explore, we see they are different. This, for example, if you're running Postgres, this is a container for Postgres database. If you want to use this, you come to the dashboard and hit this for addition. Then you give I did, like, yeah, you see the name. Let's say Postgres. Postgres is quite big, that's why I don't want to run it. And let's say Postgres, then you say the image, this is the name of the image, the name of our container, the one we want. So we say Postgres. Then how many of our instances of application we need. This is where it's according to the number we have, the number of users we have. If we have so many users and our database, each instance of our database can handle 1,000. Let's say we have 4,000. So we will come here and scale to 4,000. 4, so each handling 1,000. Then we have what we call, if you want to expose our application to a database, communicates with a front end and back end. So we say we want to have each running a port. A port is a way, is if we have not interacted with running application, we have IP and we have a port. IP, it can be a network. IP, it can be a machine, like my machine here has an IP, and they are also a network. Like when I connect to my internet service provider, they give me an IP, and yeah, so you use ports. Ports makes, you can't have two ports running for the same thing. If like let's say 1992, I was using it on my application here. I can't use 1992 again for some different. So it's running, that port is taken, and there you can check the range for the ports you can have on your machine. I think from 1 to 1024 they are reserved, so you can't use them, and from above that you can use any. You can say I want to use port 1700 and make use of it. So here we have you can have Couchbase, database, images. We can have all these and pull them and run it on our Kubernetes cluster. What it does, it depends on the internet. Most of the internet, like my internet here, and pulls this. The speed will be dependent on my internet, and this where cloud hosting companies come in handy. They have quite good internet. So when you are running, no matter how huge your application is, it's not advisable to run huge containers. It's advisable to use as small as possible. They have good internet. They can have your application starting very quite fast. So, for example, when let's say we bought some machines, not bought, we what do you call them, renting or what, some machines from, we call Amazon EC2. Amazon EC2 is a cloud hosting for infrastructure as a service. Then one of the servers, one of these virtual servers goes down, and they usually provision quite fast. They give you another instance. So we want to deploy, obviously some of our application has been affected, and we want to do another application, start another application quite fast, another instance of the application. So what they will do, their internet connection on the data centers, it has to be so fast that they pull an instance, a Docker container from Docker Hub. What is Docker Hub? A Docker Hub. They will pull it very fast using our Kubernetes, admin Kubernetes part. If they were supposed to be 4 and now they are 3, it will pull the fourth one very fast and start even before the other one completely dies. And that's how it does. What we have here, what we say, Kubernetes help us do, we say this is what we desire, then the system Kubernetes does for us. We desire to have 4 instances of our application. So, and we want them to run maybe on port 1700, and it needs something extra. Target port. This is what we are doing here. Where is the other one? This. We have a container port. Let's say if you are running this application, we say the first port will be 8080 and the target port will be 1992. So I'm just giving random stuff. Or let's say this will be 1995. So we have that, then we deploy. So we already had deployed some stuff before, and we saw them running. For example, here I had deployed Redis database, Nginx, and this application. Let me start this one because it's the one we did and we saw it running. Let's come here and see. We have our desired state is 0. Let's increase this to 3 and see it as goes up. Where is it? This, it says our desired state is 3, but for now we have 0. This why where we need very fast internet to do this. If my internet today, my internet is quite slow. I'm not sure why it's that slow. It should go from 0 to 3 very fast. So yeah, there it is. It has gone to 2, and you see it change to 3. Yes, now there are 3 instances. And so if one instance of this this application was running or serving 50 people, now you'll be serving 150 people, each 50, each 50, each